In this video, we are looking at doing linear programming in Python. And so we actually have 3 videos related to linear programming. The first is linear programming, where the quantities you are solving for can be fractions. The second video looks at integer programming, where it has to be whole numbers. And the third video looks at using linear programming for scheduling. And in this case, the quantities that you're solving for are binary. So you're either on shift or you're not, 0 or 1. You only have the 2 options. So there are 3 general types of linear programming. We call continuous, where it can be any value. And then we have integer, where it has to be a whole number. And then we have binary, where it has to be 0 or 1. So we're going to start with our continuous linear programming. And so we're going under process design. So we're here at drstephpowers.github.io/mgmt-in-python. And this will link us to our Python worksheets if you want to work along or use this code for your own project. So we go here under process design to linear programming, because what we're trying to do is figure out what quantity we should be producing when we have multiple things that we make. And so we want to open this in Colab. So click on this little button here on the top. And so that you can run the code yourself and you can manipulate the code and use it for your own purposes, make sure you sign in. This will sign into your Google Drive. And you can copy this to your Google Drive. It becomes your own. You can do whatever you want with it. So I'm just going to switch over where I am already signed in. So to get us started, we're going to need a couple packages. They aren't readily available in Google Colab, so we need to install them first. So we're going to do a pip install for what is called Pulp, P-U-L-P, the LP for linear programming. So we need to install that because it's not already in the system. And then what we'll do is we'll import it once it's installed. We're also going to need to import pandas so that we can manipulate our data. We're going to import NumPy so that we can do math. Well, we can have Python do the math. And we're going to import matplotlib.pyplot. And this is going to allow us to graph. So we'll run this to import these packages. And then we're also going to import our Pulp. And Pulp has lots of different parts to it. As I said earlier, we're going to do continuous. We also have videos where we're doing integer and binary. So we're going to import all of it. So we're going to do from Pulp import, and then you see that little star there. So bring it all. Okay. All right, so we're going to do our linear programming here. We're going to do our continuous. Now you have some choices when you're doing linear programming. Are you maximizing or are you minimizing? So are you trying to minimize cost? Are you trying to maximize profit? You'll need to decide that and specify it. The other part of linear programming is the constraints. So what linear programming is where you are trying to solve multiple formulas simultaneously. And we're getting Python to do it for us. So let's look at an example for how this would work. Your company sells chocolate chip cookies, we'll call it product X, and sugar cookies, we'll call product Y. The chocolate chip cookies take 2 cups of sugar and 3 cups of flour to make 16 cookies. So 16 cookies in a batch of chocolate chip. Sugar cookies take 3 cups of sugar and 1 cup of flour to make 24 cookies. You are constrained by the availability of supplies. You have 42 cups of sugar, you have 42 cups of flour on hand, so you can't get more in, you got what you got. We want to maximize our profitability, so this is a maximization problem. We need to produce at least 50 cookies to meet demand, and we can look at the profitability of the cookies. So we make $1.10 for the chocolate chip cookies, and we make 80 cents for the sugar cookies. So how many batches of chocolate chip and sugar cookies should you make? To do linear programming, whether you're doing it in Excel or in Python, you really got to start by building the formulas. So let's make a list here and then we'll put them in Python. So let's start by, what do we want to maximize? We want to maximize our profits. So how do we calculate our profits? Well, we make $1.10 per chocolate chip cookie. And every time we make a batch of chocolate chip cookies, it makes 16 of them. So 16 times the number of batches, we'll call it X, times $1.10 gives us the profit from all of the chocolate chip cookies. And then for the sugar cookies, we make 80 cents per cookie. And when we make a batch of sugar cookies, it makes 24 of them. So our profit is going to be 24 times the number of batches of sugar cookies, 24 times Y, times that 80 cents we make per cookie. All right, we need some more formulas. These are going to represent the constraints. So we only have so much sugar. We have 42 cups of sugar. 2 cups of sugar go into every batch of chocolate chip cookies. So 2 times X plus, and then 3 cups of sugar, so 3 times Y. However many batches of sugar cookies and chocolate chip cookies we make has to be less than the 42 cups of sugar that we have. Okay. Now we have 42 cups of flour. So when we make a batch of chocolate chip, that's 3 cups of flour. So every batch of X is 3. And then we have every time we make the sugar cookies, 1 cup of flour. So 1 times Y. Y being the number of batches of sugar, X being the number of batches of our chocolate chip cookies. Again, less than, and here the 42 cups of flour. The other thing we need to look at in terms of our constraints is that we have to make at least 50 cookies. So that means 16 times X plus 24 times Y. So every time we make a batch of chocolate chip, we make 16 cookies. Every time we make a batch of sugar, we make 24. That has to be more than 50 total cookies. Okay. So we've taken all of our information and now we're going to load that into Python. So let's look at how we do that. All right, so in Python, once you have your packages running, what you want to do is you want to define your model. So we define our model using that pulp package by saying LP problem. So just write LP problem. And then here you can give your model a name. This one's about cookies. So in quotes, we've written cookies. You can call it whatever you want. The other piece is you need to specify, is it a maximization or a minimization problem? Here we are going to maximize. So you're simply defining the model. Now you need to define your variables. We have our X and our Y. So here you use the command LP variable and then give it a name. So X was the chocolate chips. So we're just going to call it chocolate chip. And then you need to specify, is there a minimum and a maximum? So are you constrained in terms of what X can be? Well, X at minimum is 0, so we can't have negative numbers. And then we'll give it no upper bound. So X can be any amount as long as it is 0 or more. And then we're doing continuous. The next video will look at integer, which is where you have to have whole numbers. But since X represents batches, we could have, for example, half a batch. So we define our variables here. X is going to be chocolate chip. It can be 0 or more, and it can be fractions. Same thing with Y. Y is sugar cookies. It can be 0 or more, and it can be fractions because we can have fractions of a batch. So we need to define the variables. The next piece here is to define the maximization problem. So if we go back to our problem here, we wanted to maximize 1.1 times X times 16 plus 0.8 times Y times 24. So the number of cookies times the number of batches times the money we make off of each cookie. Okay, so we take that back over, and that's what you see here. 1.1 times 16 times X, 0.8 times 24 times Y. We load that model in. So if you have a different problem, you would simply change this section here. You're going to have this model plus equals. Okay. And we'll use that same coding as we add the constraints, model plus equals. So it's showing all of this is combined in terms of the problem that we have. So we have defined the model as a maximization model. We have defined our variables as being 0 or higher and that they can be fractions. We have specified that we want to maximize this formula here. That is the formula for our profit. And now we need to enter in our constraints. So we have, if you recall, 2x plus 3y is less than or equal to 42. That's how much sugar we have on hand. So 2x plus 4y less than or equal to 42, and you can give it a name. We'll call it sugar. And then we specify our constraint related to flour, and we found that before. That's the 3x plus 1y must be less than or equal to 42. So here's our 3x plus 1y must be less than or equal to 42, and we name it flour. Then we need to make sure we have at least 50 cookies. So we have 16 cookies in a batch of chocolate, so 16 times x, plus 24 in a batch of sugar times the number of batches of sugar must be greater than 50. So we could enter these separately into each line of code, or we can put them all in here like this, and we simply run it. So if you're doing your own linear programming, you would simply trade out this part for your formula and then give it a name so that you know that constraint. Then the last part, you don't have to mess with this line of code at all. This says take the model and solve it, and then give us the variable names and the values. So it is running the model, and then it is printing out the variable name and the values. And so when I run that here, what we get is that in order to maximize our profits, we need to make 12.6 batches of chocolate chip cookies and 4.2 batches of sugar cookies. We can show this as well on a graph, and that's why we install the package of matplotlib.pyplot, or imported the package. And so to do that, that's what this line of code here is. So what this is saying is that it's going to create, just this first line here, is that we're creating a space, and it's really just saying, okay, well, here's the range. So it's going to range from 0 to 20, and since I just wanted to make it kind of square, 0 to 20 cookies of chocolate chip, 0 to 20 cookies of sugar cookies. That's what this is. It's basically creating the box. So you could change it to something else. The 400 comes from 20 times 20. So the grid is 0 to 20, and since I want it 0 to 20 on both, it's going to be 400 there. And we can create a mesh grid from that. Okay, so this is just simply to lay out the plotting space, because since you're not plotting actual numbers, you are plotting formulas, you need to give it values in which it's going to put into the formulas. It's going to put in for x and y. So what it's doing is it's saying, okay, well, I'm going to put in for x and y, this range from 0 to 20, to create the grid. And then what we do is we give it the formulas. So these are the same formulas that you had before, and we use something called IMShow. And so we're going to plot that. And so you'll notice here we have our 2x plus 4y is less than or equal to 42 in parentheses, and 3 times x plus 1 times y is less than or equal to 42 in parentheses, and our 16 times x plus 24y is greater than or equal to 50. Those are the 3 constraints that we're limiting our number of batches, and we're telling it that this is going to produce integers. So convert into numbers, okay? And then we want to show from our minimum x to our maximum x, from our minimum y to our maximum y. And it's going to gray in this area that is the constraint by these variables. So each formula is essentially a graph line. I'll just show you here. So here we have one of these formulas becomes this line here, one becomes this line here, and one becomes this line here. We have our 3 formulas are creating 3 lines on our graph. And we're simply showing it to gray in the area in between. So this here is the minimum 2.5 batches of each to get us our 50 cookies. But then what we have is this line here is to limit the amount we have of sugar and limit the amount we have of flour, right? That's these two here. So really the solutions are limited to the gray space on the graph, okay? This angle right here is where we end up as the optimal solution. So notice that chocolate chip equals 12.6 and sugar cookie equals 4.2. That's right here. That's that curve. Because we want to maximize profitability. So we want to be as high as we can in this gray space, okay? But because of the constraints, it's going to be where the angle is going to be your optimal solution. So we can show all the options here that are within our constraints, but because we want to maximize profits, we want to be as high as we can be, okay? And so because we want chocolate chip cookies and sugar cookies, it's going to be at the angle. So that's what this graph is showing you with this IM show. And so all you would need to do if this is you is you would need to replace the 0, 20, and 400 if your solutions are much larger, right? I'm looking at a range between 0 and 20, and this is just that upper bound squared. And then you put in your constraints, your 3 formulas that you have. Maybe you have more, they go right here. And then the rest, you just run. The X label is what you want to call what's on the horizontal, so we're calling it chocolate chip. And the Y label is what we're calling the vertical axes, which is our sugar cookies. And we simply run it. You could already see it. And there we have our graph. So we can use linear programming to have it solve multiple formulas for us simultaneously. You're going to need a maximization or a minimization problem, so it knows which part of the gray space to choose from. And then you're going to need these constraints. Greater than some number, less than some number, what's limiting your choices from being infinite possibilities of solutions. And then you need to specify what variables are you solving for and can they be fractions. In our next video, we'll look at the same kind of problem, but where we need integers, where we need whole numbers.